Okay. Hello, and welcome to Component Rescue Board Review. My name is Harrison, and today we are going to be working on quite a few computers. The first of these is going to be a 2009 13-inch MacBook Pro, and the board number for this board is going to be 8202530. So, problem with this board is listed as no power, and I'll show you in a second. Let me switch over to there. As you can see on the charger right there, there is no light on it. And this board is also fairly liquid damaged, especially in this area right over here. So what we're going to do is we're going to figure out why there's no light on the charger and see if we can get that working again. So the first thing that I'm looking at right now that could be causing this problem is going to be this transistor right here. This transistor on this pin puts out the 18 volts to the machine, and one of these or two of these or three of these are ground, or one, I think that one's ground, and then these are hooked up to the power. And basically what this transistor does, I'm pretty sure, is that if the machine is using too much amperage, it'll shut the power off to it to keep it from damaging itself or catching the board on fire. So if that's damaged, then there won't be any power going into the computer. So I'm going to see if I can just brush that off a little bit. Usually these are pretty good at not getting damaged from liquid, but every once in a while one of them can get killed. And this may just need to be resoldered to get it good again, because that's looking pretty decent right there. I may just need to touch that up. So my soldering iron's heating up right now. I forgot to turn it on a second ago. It's kind of bright. There we go, that's a little better, I guess. Auto brightness isn't working too well right now. There we go. So I'm going to try touching up this resistor, or not resistor, transistor, and we'll see if we can get it to work. The other thing I'm worried about is these probe points down here. Seem to be pretty far gone. Actually, they seem to be gone completely, which is kind of understandable since there's 18.5 volts right there. But our soldering iron should be heated up now. I'll turn my fan on. And we'll go ahead and touch up this pin and see if that helps us out. There's a little bit of crap down in there. It's got to kind of scrape a little bit and get some fresh solder on there. Hopefully some good. Just kind of scrape and scrape. And now, as you can see, it's starting to take some solder again. So I'll put some flux on and we'll resolder that joint, and then we'll see if that gives us any progress. This probably won't, but it's a good starting spot. Okay, so now grab our charger, stick it on there, and that doesn't give us any progress, sadly. So next thing I want to check is I just want to keep looking around the board and see if there's any other damage that could keep this from working. There's the charging circuit. Oh yeah, and I'm not sure how many of you have noticed. However, let me see if I can zoom in on this. So this is directly above the ISL 6259 on these 2009 MacBook Pros. Sorry, I don't know why my auto brightness isn't working. But on these two caps right here, so there's a resistor right here, and two caps here for the current sensing circuit. However, on these, it's not on the schematic or the board view, but there's always this little resistor attached right here, and I'm not entirely sure what it's for. I'm guessing it was something that they decided the board needed after it had already been manufactured, so they just kind of soldered it on there. Okay, so what I want to check out is going to be the PP3V42 regulator. Well, actually, first let's test to see if we're getting PP3V42, because if we're not, the SMC is not even turning on. Okay, and we'll switch to the board view. And where can we find that? PP3V42G3 hot. And we're going to look on the other side of the board. So we can find that in a lot of places. Oh, and the other thing I want to look at is this corrosion right here where the J tag is, because that could definitely be keeping us from turning it on. So I'm pretty sure that right there is going to be, yeah. So this, what we're looking at right here, is our PP3V42 regulator IC for this. And as you can see, it looks like crap. I am not even going to bother testing that. I'm just going to go ahead and put a new one on there. Hopefully I have one, since I only have like one or two of these boards. Let's see. Okay. So what all am I going to rip off? Let's see. We're going to take off probably at least the IC, and maybe the resistor on the top. Everything else just kind of looks covered in hair and other crap. But I think it'll all be fine. Oh, wait. I almost forgot to switch you guys back over to here. Here we go. I meant to show you guys the board view. I don't think I did. Here's the board view. The little thing that's highlighted is the PB342 regulator. And as you can see, it's covered in corrosion. So we're going to go ahead and get that pulled off. Sorry about that. Okay. And as you can see, this area looks like absolute crap. Sorry this looks so bad, but this on the camera, but these boards are very reflective with the lighting. But you can still kind of see, you know. I also don't know why the frame rate is so low. I'm still trying to figure that out. Because at this resolution, my camera should be running at 30 FPS. So I don't know if it's some problem with the driver or something else. But hopefully I'll get that all figured out soon. Okay, so let's get this all cleaned up. And we'll go ahead and wick this all off. Where did my scissors go? They fall off my wrist. That means I'm crazy. I don't see them. Oh, here they are. Okay. And then we'll wick this all off. And we'll clean it off with some cotton swabs to get rid of all corrosion. And now, as you can see, we got all of our pads back. So now we can go ahead and solder a new chip onto them. A new chip. We'll clean that off a little more. And I guess I'll go ahead and add a little bit of flux. And I'll put some soldering pads and get the new chip soldered on them. And it looks like right here, if this pad is broken, I'm going to see if I can scrape away. Yeah, that pad is gone. So I'm going to try to scrape away something like actually, I don't think that pad is gone. So let's try putting some solder on there. There we go. And that's still connected down there. That pad is definitely partially gone. It should be on fine now. We can zoom back out. I'll add some flux. And then we'll grab our replacement chip off of a donut board. Okay. I'm going to get that in place anyway. And I'll press it down. And our little flux and remove that little ball of solder from there. Cool it off for a second. And then we'll check and see if we get light. Oh. Let me grab the charger. Okay, waiting for my audio to turn on. And actually, I'll put this over the fan so you can just see if it goes ahead and turns on. Well, actually, this isn't going to turn on because I have to use the power on pad to turn it on. So we'll put it right over here where this is, and we'll plug it in, and we'll see if we get a light in just a second. Okay, there we go. And we still get it. No light on the chart. Yeah, that all looks fine there. My guess is that there's probably some problem with this over here. So what is all of this? Okay, so that's my backlight fuse and something that's connected to PP342. So first thing I want to do is I want to see if PP342 is short of the ground. So I'll put that probe on ground and that probe right there. And it is not short of the ground. So I'll go ahead and plug it in and we'll see if we're getting PP342. We are getting it now. Okay, so that's a good sign. So I'll unplug it and I want to check a few more areas on the board now. So I was just checking that spot right there. I'll switch back over to the microscope. So PP342 is present now. However, we're still not getting a line on the charger, which means that either the line between the SMC and the charger is bad, the SMC is bad, or the SMC is not turning on. So let's see, do we have any liquid damage around here? We got a little bit of green on some of those, but I don't see anything that would make me think the SMC is at fault. What does it look like back there? That looks nice. So what I'm going to do, I'm going to look at the board view, and I'm going to trace adapter sense back to see where it goes. Can you guys see that? Yeah. Okay, so adapter sense is what the charger uses to talk to the SMC. So first it's going to go to this little resistor right here, and then it's going to go to this, which is the sys1 wire, which is powered by sorry, that's powered by SMC BCAC OK VCC. Now for that to work, this little transistor over here needs to be turning on, and a lot of the time it will not be. And as you can see right here, it is covered in liquid damage. So it could very, very likely be bad. So I'll probably want to go ahead and at least see if that needs to be touched up. Or there might even be a broken trace on it. Because actually that chip doesn't look too bad. Let me switch you guys back over to the microscope. Okay, there we go. Can you guys See that? There we go. See, the chip itself doesn't look too bad besides that one leg. However, the traces that I'm pretty sure go to it look like they are gone. Specifically this one right here. And let me check on the board view what that one is. That one is going to be PP3V42G3 hot. So if that's missing from this, then it has no way to power the circuit. So there's no way for the charger to talk to the SMC. So I'm going to go ahead and plug this back in. I'm going to measure at that spot to see if PP3V42 is present there. My guess is that it's not going to be. Let's move this a little bit so I can see. That's that pin right there. And just like I thought, it is not there. So what we're going to have to do, let me double check just to be sure. Yep, it's not there. However, we are getting it right here. And I'm not saying it's not completely there. We are getting, I think it said about 1.2 volts, which means that the line is partially broken and is working as a resistor instead of as a wire. So there's a real easy way we can fix that. And what we're going to do is we're just going to run a little wire from this diode right here to that little chip over there. So let's cut off a piece of jumper wire. And I can zoom out a little bit for this. So we'll add some flux there and some flux there. I'll need that wire in just a second. And we're going to add some solder onto here to make it easier to solder to. Okay, and I think I'm going to start over here. And I'm going to solder this little wire right there. And I'm probably going to have to turn this a little bit. Okay, we got that soldered onto there. And I'll use my tweezers to hold it in place right there. And I'll do a little bit of scraping to make sure we get the enamel coating off the wire. And I'll even add a little bit more solder just to be sure that that's really on there. Okay. And then we'll break this little wire off. Excess. Okay, and now we will go ahead and try it again. Where's my charger? Here we go. Okay, there we go. And now, as you can see on the charger, we got a green light. That's a good sign. So now let's see if this board will turn on. So for these, on these older boards that don't have the Core i-series processors on them, the older ones with the Core Duos and the Core 2 Duos. I mean, I hope you're not working on any with the Core Duo, but these older ones with the Core 2 Duos that I still work on, they do not turn on automatically, and there's these things called power-up pads on them, and I'll show you how you can find them real quick. You can just go over to the board view and you'll search for SMC on off L, and there will be one of those somewhere that says it's a resistor like this. However, when you check it on the board, there won't be a part there, and what you do is you just get a screwdriver or tweezers or anything, and you just touch those two pads together and it'll act like you press the power button. So there should be some on this side too. Yep, right here. So where's that going to be? That's going to be over here. So what I'll do, let me switch back over to the microscope. I will put the fan on here so you guys can see. Actually, I can't because then I can't reach these. Where was this? Right, that's the wrong side of the board. It is right there. Okay, there we go. Touch the power-up pads, and now as you can see, the fan is spinning. When I unplug it, the fan stops. So that means that this board is likely fixed. I'll go ahead and put this board in my pile of ones to test. I'll run all the Apple service diagnostics on it to make sure everything else is working. But besides that, this board should be good. So just to recap, we replaced the, excuse me, wait, where is it? There it is. We replaced the PP3V42 regulator, and we ran a little jumper wire right there because the trace was broken. Okay, so throw that back in there, and we will move on to the next video. So let's see. This next one is a 2010, I think. Yes. Yeah, this next one's a 2010 that has no light on the charger. So let's go ahead and get it taken apart so we can see what's going on with it. Where is my T6? There we go. And if you guys watched the video I did earlier today, I said I would be editing that video along with a bunch of my other ones. I'll be doing that with this one too, and having individual videos for each of these boards I worked on with abridged versions of the diagnostics, where I basically just go through each step and say, do this, I did this, then this, then this. Now it works. in just a sec, and I'll have this board out, and we can get started on it. Okay, grab a little baggie for the screws. Oh boy, this one's really stuck in. There we go. Okay, so of course, just like always, now that this is out of the computer, I will go ahead and test it out again, see if it works now. Because surprisingly, sometimes people might think you're weird for testing everything out of the computer, but you'd be surprised. I've had quite a few computers where before I realized that other components could keep them from working, it would drive me crazy because I'd fix the board and then I'd put it back together and then it wouldn't work. And it took me a little while to realize that things like the trackpad or the keyboard can actually stop the computer from turning on because they're connected to things like PP3B42. So if they're shorting that to ground, then it'll keep the computer from turning on. And a lot of the devices that you plug in have access to your important power rails. So usually the first thing you always want to do when you're testing something like this is, oh, hello, what is that doing? So the first thing you always want to do is take it out and just plug the board in with the MagSafe and see if that fixes the issue with it. So on this one, we still have no light on the charger. So first thing, and I bet you guys will trust me, I showed you on the last one. So first thing, I'm going to check the lead charging circuit over here. And as you can see, there is a little bit of corrosion on it. That is really out of focus. There we go, that should be better. Let me switch over to the other board. It's the 2879. There we go. Okay, so according to the board view, that stuff that has corrosion on it has nothing to do with this not having lead on the charger. So just like on the last one, ooh, there's our PP342 regulator. That doesn't look too good. So just like on the last one, this little thing over here is going to talk to the charger, and it's going to have PP3B42 on it. So I'll go ahead and check that and see what voltage we're getting there. Ooh, we're only getting 1.3 volts. That's not good. Let's check somewhere else. Like right here. What are we getting here? 1.27 volts, which means there's a problem with our PP342 regulator. So this one is going to be somewhat of a similar problem to the last one. So Do I have a 2010 board over here? I don't think I do. Unless maybe this is one. Nope, that's an 08. That's a 9. That's an 11. And another 2011. Give me just a sec. I gotta go grab a 2010 MacBook Pro board. Okay, got one right here. Why are the lights doing that thing where it's changing? There we go. Okay, so let's go ahead and pull this regulator off and stick a new one on. Okay, come on, get off my tools. And just like last time, we'll clean this up. But this isn't going to need quite as much cleaning up as the last one. Since this one, thankfully, is not missing any pads. This one, I don't have to wick it all the way, so I don't really think it's necessary. I'll just go ahead and pull the new one off and slap it on there. Okay. Put that in place. And we'll press that. Get all the extra solder out. Oh, a bit of flux. Make sure that's all nice and fluid in the case. One. Okay. And let me double check, make sure there's no short. Um, nope, we're at about 2 ohms. That should be about right. Put this in front of the fan, let it cool off for a second, and we'll see if this works. How's the other side of this board working? Not too bad. Okay, go ahead and plug this in, and hopefully we will get a light on the charger. Nope, still no light. Are we getting 3.42 volts? Let's see. Nope, we're still getting 1.27 volts. So the corrosion all over that is not what is keeping this from working. So let's go ahead and take another look at this. So what's this chip right next to it? Okay, that's going to be the SMC reset circuit, and we'll probably have to end up replacing that too. That is not what I'm worried about right now. What I am worried about is this. Okay, so where are we getting the power in for this chip? We are getting it on pins 6 and 8. Wait, is this? Yeah. Okay, yeah, this is the chip I'm thinking of. Okay, and it's also on that capacitor right there. So, next, I'll plug this back in, and I'll measure the voltage on that large capacitor right next to the chip we just replaced. There should be 18 volts there. Or sorry, 16. And we are indeed getting 16 volts there. Which means that the input to the chip is there. Which that means one of two things. Either my output is shorted, which I thought I just checked, or there's a broken trace somewhere. We'll find it right. Yeah, we have over 100 kilo ohms, so there's no short. So, okay, there's the feedback. So the other option is that the feedback right here is destroyed. So let's check the resistance of these two resistors. Because if these resistors are not good, then the circuit will not work. That one says open line. That one says about 170 kilo ohms. Oh, here we go. So I'm going to switch over to the schematic and we're going to see what these are supposed to be. So R6995 was reading about 600 kilo ohms. And sorry I can't show you guys the schematic. I gotta open it up. 2879. R6995. Okay, so that's supposed to be 348 kilo ohms. So let's see if that's actually going to read a value higher than that. Because if it is, then we're going to have to replace it. I don't know, that seems to be fine. So pin 2, what is pin 2? Pin 2 is the bias. So the other thing is that this cap right here could be shorted. Is this cap shorted? No. Let's see. Does that connect to this little resistor? I think it does. Yeah, it does. Okay. So I'm going to check the feedback and see what it is, because my guess is that the feedback is not working on here. So on the feedback, I'm getting 0.675 volts. And we should be getting 0.675 volts. 3.42 divided by 548 times 200. We should be getting about 1.25 volts. So I was right in that those resistors are not the correct values. So let's go ahead and swap these resistors out. I'm just going to go ahead and replace both of them. Since I don't know if a specific one is bad, it's probably best to just go ahead and do both. That's going to be this and that. And I'll put some fresh solder on those pads. And then we will stick the new resistors on there. And hopefully that'll fix our problem. Okay, that looks soldered on nicely. Put that in focus for you guys so you can see. Yay, 2 new resistors. I need to write it up. There we go. Okay. Now we'll plug this in, and maybe if I'm lucky, we will get a green light. Still no green light. That means something is keeping that from working properly. Okay. Actually, you know what? I just thought of why that was half of what it was supposed to be. It's not the feedback resistors, it's because PP342 is half of what it's supposed to be. So that actually makes sense. You know what? Let's check the resistance to ground on my parts board just to get an idea of what we're looking at. That's not helpful. That's telling me over 7 million ohms, which I know is not right. But then on this one, I'm getting an open line. What about from there? Huh. What in the world? Okay, my multimeter is not working. Okay, so right here, I should have a connection with PP342, but for some reason, it's saying open line. Actually, I think I may know my problem. I may once again have to run a little wire over here. Let me check somewhere else on the board that has PP3V42 just to see if I'm getting the same result. I'm going to bring this back a little more and focus. So let's see if from right there, right there, do I have any resistance? I have no resistance. However, from there to over here, I do have resistance, which means that there is likely a broken trace somewhere. Where that trace is broken, I have absolutely no idea, and don't really want to take the time to try and find out. So what we're going to do is the trace broke into here. Then I run a wire from here. I can't. Okay, so this right here, what we're going to solder the wire onto, this is the SMC reset circuit. It looked kind of trash originally, but now it looks pretty okay. But there is about a 10 ohm resistance going across here to there, which there definitely should not be, which means that there's probably a broken trace. So we're going to run a little jumper wire over there. So this one is pretty much exactly going to be like the last one. I did. So let's grab the wire. And we'll grab some solder. Put some fresh solder on there. And we'll put some fresh solder on there. And then we'll run our little wire. So I'll start it over here. I'll hold it right in place with my tweezers. Then I have to add some more solder. And a tiny bit more solder. Okay, that's just about nice and all over. Okay, there we go. Beautiful. And we'll run that little wire over to here. And turn this a little bit so I can reach it a little better with this. Okay, and now we'll plug it in again and see if we get a light on the charger. And still no light on the charger. Getting a very dim one. Okay, and this is starting to hurt my back. Okay, so what we're going to do, we're going to measure over here. And we're going to see if PP342 is actually making it over here. It still is not. They're still just getting 1.27 volts. What in the world is causing that? Where does the power go in? It goes in right there. That's unconnected. The only other thing I can think of is that the trace is broken to where the power goes in, which it doesn't look like that's the case. But I can't think of anything else that could be keeping this from working. Ooh, this is a tricky one. Let's check around the inductor on this side. There's the inductor for it. I mean, honestly, the only thing I can think of is that there's got to be a short somewhere. But I'm not getting a short anywhere. Hmm. This one's really tricky. I may have to come back to this one. Let me think about this one for a little bit. I'll come back to it in a second while I move on to the next one. This next one is. That's not it. Okay, let's see. This is a 2010 GPU panels. So this should be a really easy one. Now let's go ahead and get this done. This one shouldn't take any effort or any time. And I'll keep thinking about what could possibly be causing that one not to work. Because I'm trying to think, if we got the correct input voltage and the feedback is working properly, then we should be getting the correct output voltage. I mean, what I always can do is I can try pulling the, I can pull the inductor off and see what kind of voltages we're getting then. Because with that off, there's not going to be any load on it. So I should be able to see then what voltage the circuit is producing by itself. I mean, at that point now, if it's because something is shorted on PP3 before too, oh boy, that may never be solved, especially with that small of a short. It's really confusing though, because it's limited to 250 milliamps. And it's at 1.2 volts. Which means it's trying to draw 750 milliamps. Which means that probably something is shorted on it, but it's very, very small short. Which is never fun or easy to find. And on a board that old, probably isn't worth the time or effort. Because to do that, you basically have to pull off everything that's connected to that power line until it starts working again. And then you got to replace that part and then put everything else back on. And it just takes a very, very long time. Something that old as a 2010, I just really don't think it's worth the time. Especially since it's not for a customer. A lot of these boards are ones that, these are my boards that I've been working on. So they're all just kind of for fun. But really, I'll probably end up, I'll probably end up selling a lot of these computers. Why is this not correct? Thought I got all the screws back out. Yeah, I did. I got all the screws. Why are you not coming up? You must be caught on something. Oh, you are caught on something. There you go. Be free. Be free, little MacBook. Be free. Oh boy. Ah, finally. Okay. Grab a baggie full of screws. And of course, this board I'm about to work on is a 2010 that is GPU panicking. And it's a very common problem with these models. Actually, GPU panics are a common problem with a lot of models of MacBook Pro. But with this specific one, as I've outlined before, it is a problem with a capacitor on it. So it's going to be this capacitor right here. And to get it to work again, you just got to replace that capacitor. I always replace it with a properly sized one that will not fail again. Where's my screwdriver? There we go. So get the heat sink off, and then we'll go ahead and get that little capacitor replaced with a brand new one that will not fail. And what that capacitor is hooked up to the GPU power. It's basically the GPU V core before it goes through like the current sensing and processing and that kind of stuff. It's just a smoothing resistor for it. And whenever it goes bad, the voltage starts to fluctuate. And because the voltage fluctuates on the GPU will crash. And because of that, you will get a kernel pin. So by replacing that capacitor, it will stop kernel pin. There we go. Wonderful. And we'll back flux to make this come off easier. Grab the tweezers. Heat the board a little bit. These boards do absorb a lot of heat, and you gotta be careful not to heat up the CPU right next to this, otherwise you will probably end up killing it. And then you get it nice and close to finish melting the solder. Should be about to come off. There we go. Add some more flux. And we'll put some fresh solder on the pads. And there is my capacitors go. So I'll grab a brand new capacitor and we'll get it soldered on there. And I'll press it down on the board. And I'll clean the solder balls up. And when we're done, I'll clean up all the flux off the board. Since this one does not need to be emphasized, the only issue with it was the GPU pad. So I'll grab a fresh cotton swab. And we'll try and clean up as much of this as we can. Get it looking all nice, new, and pretty. So it looks like No one ever messed with this. I think that's about as good as that's going to be. That was pretty good though. Still a little bit. There we go. That looks pretty good. Okay. And this one, I'll just put some new thermal grease on there, and it should be good to go. So I guess now we need to get back to the one that's missing, PP3V42. Let me find somewhere to set this. Like I said, there's a couple ideas of stuff I can do. I think probably what I'll do is pull the inductor off to see if it's on the side of it's to see which side of the circuit. Sorry. PP342 is being made. Where is that computer? Is this it? Yeah, this is it. So this one, this one's gonna be a real tricky one. So you know what? I never tried any DC because this one, to be honest, looks like that. I may as well see what happens if I stick another one on there. It's not like it's gonna hurt. Let's see. Now a good one. Of course, we still get my light. I'm actually just going to test it with this one because the other one, like I said, looks like complete crap. I'll look back this section over here. And I want to check on the board view what exactly all of these parts are. So we'll go over here. All these ones, okay, that's backlight circuit, of course. What is this? SMC N follow, P follow? I have no idea what that is for. Interesting. Interesting. You know what? I'm going to go ahead, like I said, and pull that inductor off. This is going to be a little tricky because of the positioning of it. It is right here, like right next to the CPU and right next to the SMC. Neither of which I want to beat up too much. I'll go what's there. That one there. Now let me switch you guys back over. Okay, let's go ahead and get this pulled off, and then we'll go from there. This is going to be kind of difficult to. I don't think I can do it. There we go. Okay, so now that's off, I'm going to set it off to the side, because we're going to have to put it back on. I'll cool the board off a little bit, because that's one thing too. You never want to put power through a board when the components are too hot, because it can actually damage some of them. It won't necessarily damage them, but some of them can if they're too hot. Because all the regular components like the resistors and capacitors should be fine. Some of the like tantalum capacitors might not be, but heat actually can affect things like the resistance and capacitance of many different materials. So if something is incredibly hot or incredibly cold, it may not uh, create the same amount of power as if it were at a normal temperature. Okay, so for this, I'm going to flip this over, like so, plug it in, and we will measure it right there. You know, actually, I don't think that this works on here, because there's not a fuse or something you can take off. I think I've tried doing this before and it didn't work very well, but we'll see. It's been a while. I'm just trying to think of stuff to do. See, there we got 150 millivolts. Okay, 155 millivolts sounds right. You know, what if it is the coil? You know, a lot of people say it's never the coil. The coil is never bad. What if it is? I mean, I honestly can't think of what else it is. We're getting about the same resistance reading from a normal one. So the resistance to ground is normal. The feedback is all fine and normal. Everything seems normal, except for a few small things. And this is one of them. I mean, it has to be. I don't know what else could possibly be wrong with this. I just honestly don't. My mind is completely blank. Okay, let's see if trying it with a different coil works. This coil actually works a lot nicer somehow. somehow. But we'll see. We'll see what it does. Maybe if I'm super unlucky, then something will be shorting at the ground and I'll have to pull everything off one by one, including the SMC, because remember the SMC uses PPV before too. This board is really making me hate myself. I thought this would be an easy one, but maybe not. And you know, some of these, I may just have to end up fixing this off stream and then telling you guys the solution. Because, I mean, some of these take me quite some time to do. Okay, let's see. What do we get? We get a light? Nope, still no light. I'm honestly lost at what could be causing this. Let's check it here. That little line I saw on there came undone, but that's okay. I just want to see if we are still at 1.27 volts. Let's check it. Now this is really strange. I mean, it could be that the feedback trace is broken too. I mean, I thought it looked good. I'm just trying to think of what could possibly be wrong here. Zoom good. I mean, all of that looks good. It all looks just like it should. Which is really strange. I'm certain there's no short to ground. No, no short to ground. None of these are short to ground. What are these? Okay, that's right. Is this shorted? No, 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 no. Hmm. You know, I think I'm just honestly gonna go ahead and replace the rest of the PP3 circuit that I haven't already, and see if that makes any difference whatsoever. Because obviously everything else I'm trying is not working. I'll get rid of those two, and I think that's everything that I haven't replaced. I know for sure is not working. And I'll go ahead and reconnect this wire. Not that it's probably going to make any difference, but I mean, there definitely was a small bit of resistance to run. That's not super straight or taut. That's the thing. Ooh. Okay, and what do we get now? Oh my god, that's still pretty hot. I'm gonna put that above the fan instead. Okay, that's fairly cool. Let's go ahead and plug it in. And still no light. Which means that there's probably a short somewhere on PP3V42 that's causing it to pull slightly too much power. Which basically, since this board is 9 years old, means that it's not really worth fixing. So that's kind of too bad. Hold on. Let me see if I got anything else to fix that I can stream. Aha, here we go. Here's something to fix. This one is not a full computer. However, we can still work on it. This is a 820-2915, which is going to be a 2011 15-inch MacBook Pro. These boards are known for the GPUs dying in them. However, this one has quite a bit of liquid damage, and I would guess that it does not turn on. So, let's go ahead and see what happens when we plug it in. Okay, so you plug it in, absolutely nothing happens. Once I get it out of here, I'll show you guys. I'm gonna guess though, probably has something to do with that. Where are my screwdrivers? Okay, here's my T6, and I need my Phillips too. What I do? Oh, here it is. I dropped it. Okay, well, this is great. I'm unscrewing this screw and it's not coming out, but a bunch of metal is coming out, which means that that screw is completely broken. What a wonderful stripped out screw. I love it when that happens. Okay, let's finish taking this out. And we'll start taking a look at it, see if we can get it to turn back on. And hopefully, since this one's liquid damage, it doesn't have the GPU problem. Come on. Come on out. Poor thing there. There we go. Wonderful. Okay, and a little baggie of screws. Okay, there we go. Okay, so first thing I notice is that right here on the power input for the 2342 circuit, there is quite a bit of corrosion. Also on these right here, which I'm trying to remember what those are on this board. I think that those are the power controllers for the CPU and GPU. I'm not 100% sure. Let me check. Let's see, 20, no, 15 board. Oh wait, no, those are going to be for USB. Okay, so those aren't going to keep us from turning on. What do we got on the other side? Any corrosion? No, that all looks pretty clean. So I'm going to go ahead and see if this will turn on outside of the case. And we get a green light, and we get no power. Okay, first thing I'm going to check is if we actually have PP3B42. Since that circuit is completely corroded, just because you get a green light, sorry, I forgot to put my mic back on. Just because you have a green light doesn't necessarily mean it's working. Sometimes chargers will still put a light on them, even if it's not working for some reason. Not entirely sure why. Okay, that is working. So next thing we'll check will be PP bus G3 hot. So I'll go ahead and check that. I think I'm going to have to check that on the other side of the board. Yep. Okay, we'll get this flipped over. And there's some fuses down here that I can check. Should be in the picture now. And they should have PP bus G3 hot on them. Let's see, what voltage do I get? I get 12.56 volts. So that means we got PP bus G3 hot. So next thing I'm going to check is, I'll go ahead and skip the S5 rails. They are probably going to be there. If not, I can go back and check them. Okay, I'll go ahead and check PP3V3 S3 to see if it is present. Wow, this is a complete mess. Okay, so I can find that near the SMC underneath it on a capacitor, which does not appear to be on the board. Because it's probably on the other side. Okay, so flip the board over. So where exactly is that going to be? That's going to be next to this giant chip down here. So okay, so I see where it is. Oh, switched you off. There we go. So we can check for it right here. I'm going to guess it's not going to be there. And wow, surprise, surprise, it's not there. Actually, it's at 0.35 volts. So do we have PP5VS3? PP5VS3. Sorry about the switching cameras. I need to work on my hotkeys for everything. Where can I find this? I can find it right over. Oh, what is that? Interesting. That is the chip that makes PP5VS3 and PP3V3 S3 and S5. So my guess is going to be that that chip is bad since there's burn marks on it. So I think I'll go ahead and replace that, and that should bring us up from 0.35 volts. Let me see if I actually have a 2011 board. I should have one somewhere. No, that's not it. That's not it. That's not it. I know that I have one somewhere. Here we go. Here it is. Is this it? Yeah, this is it. Okay. Let's go ahead and pull the fans off of both of these boards so I don't burn the fan. And I'll go ahead and get all this stuff in place. And then hopefully we will get this computer to turn on. Okay. And I'll go ahead and take the heatsink off too, since this could probably use a repasting. And I don't want to burn up the GPU by heating up the heatsink too much. Now, I really wish I had an overhead cam for this instead of just a face cam and a microscope cam. I really need to get a better face cam too. Maybe someday when I have more money. But right now, I'm just doing all this because I enjoy making these videos. I had to pay extra to get a microscope that was a trinocular, and I had to pay extra to get a microscope camera. No, they're not cheap. Not cheap at all. Plus, currently, I'm not making any money on these videos. And, I mean, I'm even about to start editing them to make them easier to find my content. All just because I enjoy them. So we'll add a little bit of flux just to help this all flow off. And I'm really going to have to clean that up over there. This crap I can probably just... Eh, eh. Go away. Corrosion, go away. Go away. Come again some other way. Actually, don't. Never come back. Come on. There we go. See, look at that. Look at that. We have it all nice and up there. Piece of crap probably doesn't even work. So now we're going to clean up all of these pads. With some fresh solder, and I'll whip them all away. Just so this all looks nice. And where's my wick? Quick, quick, quick. Here we go. Uh, put this here. Okay. Now we'll clean this off. Make it look all nice and new again. Like the corrosion was never there. I already see one potential problem. There is a hole. That road point is completely gone. That could explain why we're not getting the proper voltages. Can you guys see it there on the top right? We are missing a road point. And it looks like this one over here next to this other little transistor is also missing. Well, what are those for? Let's find out. PP5VS3 VBST and no, that's still here, and it has absolutely nothing to do with this. But that is definitely broken. So we're going to have to run a little wire to that. First, though, let's get this chip replaced. No, actually, before I do that, I'm going to go ahead and scrape it away right here, so I'll have something soldered to. There we go. Now I have something soldered to. See, that's all fine. Okay. This is fine too. Looks like crap, but it's fine. Okay, we'll zoom back out. It's a flux. And we'll put some fresh solder on there. There we go. Okay, let's clean these up a little bit. Okay, beautiful. Okay, a little bit more flux here. What the fuck? And I'll pull our donor chip off. Alright, I got that. Let that down. Let's say beforehand that didn't look like it was working quite right. There we go. Now it's a lot better. Move our donor board out of the way. And really clean up those edges a little bit. And then we'll run our little jumper wire on there and see if we got a working board. I'll move this over a little bit. I want it flowing. It's a little bit off. Okay. There we go. It's better. Still a tiny bit crooked, but it definitely looks better. I'm gonna do just a second. I'll clean up this side a tiny bit. Okay. And then of course I decided to jump the line. I'm going to turn this a little bit. Get a better angle. I forgot to scrape away. There's no real solid capacity. Or maybe I can. Maybe I just haven't tried hard enough. Yep, there we go. Okay, so this is going to be a little bit tricky because we got such a tight space to work with. But I think I can do it just fine. Okay, we'll grab our jumper wire, 10mm wire, grab it with tweezers, and I'll put it right down in there with the tweezers. Okay, there we go. We got the wire in. Zoom out a bit so you can kind of see it. Now it's kind of pretty shiny. I don't know if you'll be able to see. But we got the wire in. Oh yeah, you can kind of see it. This little orange thing right there. That's our little jumper wire. Okay. I'll let this cool off a little bit. And I'll kind of stick the heatsink back on. Just because I don't want it to overheat. I usually don't like running computers without a heatsink on them, especially these that are known to overheat. Oh, this must be it. Is this my heatsink? Yeah, it has to be it. And I'll just stick on like 2 screws to hold it down, just so that these don't overheat. This isn't meant to cool them off under any kind of load, especially since it needs some thermal paste. It's just meant to keep it from overheating after running for a few seconds. especially since I'm going to have to take these off whenever I do corrosion removal on this. Okay, so we got that. Plug this fan back in, and I'll see what we get. So freaking messy. I did solder that on correctly, right? I'm pretty sure I did. Here, just a sec. Let me double check on that. I don't know why I think I soldered that on. Couldn't. Yeah, that's all right. Okay, we will plug it in, and let's see what we get. We get a light, and as you can see, we get a fan spin, which means that likely that's all that was wrong with this board. So after this, I will go ahead, put this through the ultrasonic, and of course I'll test it to make sure the GPU isn't dead and all this work was for naught. But right now it's looking like that's a pretty good sign that we're going to be good to go. So I think this is all the boards I have for the moment to work on, but I can go double check in a sec and see if I have maybe a few more. I might have a few more. Just maybe. Maybe. I'll lose these screws. Okay, give me just a sec and I'll check and see if I got any more boards. Okay, I got a few more that I might just be able to fix. These are all 2011s that are not, or at least didn't appear to be liquid damage. So I kind of just assumed that they were all graphics issues. Okay, this one does not have a screen. Let's get my mic back on. Okay, I mean I can at least see if any of these don't turn on. Let's see. This one works, however there is a screw inside the center. So let's go ahead and take that out. This one powers on though, which leads me to believe that it probably has a bad GPU. Which hopefully I will have a permanent fix for soon. I'm still working on getting that rolled out, but fairly soon I should have a permanent fix for these 2011 MacBook Pros. Now it won't be as great as when you first got them, because the solution I'm working on will involve permanently disabling the dedicated GPU. However, once you do that, you'll never have the graphics problems again on the computer. It'll work forever and ever. And there aren't any other really common issues with these. So after that happens, you should be good to go for forever, basically. Let's throw the screw in this bag. That one's what I thought, likely graphics problem. That's what else do I got? Here's another one, late 2011. This one has no RAM. That's okay. I'll set that there, and I'll just tell you guys what it does, and you can trust me on it. Okay, we got a green light, and we're the fan spin. So, once again, probably, yep, it's RAM beeping at us, so that's probably going to be a graphics issue. So, next one, like I said, I'm pretty sure all of these are going to be good GPUs. I just haven't actually tested any of them yet, but I'm just assuming, since they had some kind of issue and they were 2011s, that it was probably graphics. May not. You never know. But you gotta take a guess at something. Okay. Next one. Plug it in, green light, and it turns on. Bong. Does this turn on? No. It does. And then it crashes while it's turning on, probably because of the GPU. Okay, next one. And of course I'm opening all these up to make sure there aren't any loose screws or anything. You can short out the boards. Set the bottom case right there. Now turn on. Once again, probably GPU. I got one more. This last one's missing a few parts. And the bottom of it appears to be liquid damaged. So maybe we'll have something to work with on this one. Aha, this one does not power on. So we do. We have one more. Sadly, only one more little computer to work on. This one gets no power. So let's figure out why. It's probably going to be liquid. I don't see any liquid on this side of the board, which means that there's probably some on the other side. This one already has all the screws in it. That makes my job easier. Oh wait, still has 2 screws in it. Where is my screwdriver? Okay, this is going to be our last board of the night, especially now that we are at 2.5 hours. Excuse me. Okay, so I guess I will go ahead and test this outside of the computer. There's a fan right there. We'll plug it in. And nothing. See, got it plugged in. Right there is a green light. I don't know if you can see it. There's the green light. And there's no fan spin, which means that this is not turning on. So let's go ahead and figure out why. Oh, I thought I just saw the fan jerk. Interesting. I'm not seeing any liquid damage. Let me zoom it out. Yeah, we zoomed out all the way. That connector right there is broken, but that's not going to keep this from turning on. See, it looks like someone tried turning this on with the power on. I wonder if that works. Nope, that doesn't do anything. But we are getting a little bit of a fan spin when I unplug the charger. That's really interesting. Really, really interesting. Okay, let's continue looking on this side. I don't know what that white thing is. Probably thermal paste. Everything looks fine. So on this one, we're going to have to do this the hard way and go through all the power rails one by one until we find the one that's missing. So I'm going to go ahead and open up the schematic for this, and once again, sorry that you guys can't see this, but I'm going to go to the power rail page, which on this schematic, it is page 7. So if you have the schematics yourself and you want to look along, they are on page 7. So first rail we want to measure is going to be PP bus G3 hot. So let's go to the board view and we'll open up. I already have it open. Wait, is this 2915? Yeah, it is 2915. Okay, so I already have this open. Cancel. So PP bus. I'm pretty sure there were some places over here where we can measure it. Right here. On those 2 white fuses. We should be able to measure it there. I'm going to flip this around to make it a little easier for me. So we should be able to find PP bus G3 hot there. Just a sec. Okay. Let's get this plugged in. And let's measure to see if we can have PP bus G3 hot. I'm going to guess that we very likely have it. Yep, 12.56 volts. So next one, and I'm going to make this a little easier on myself by just skipping between each of the different states. So these machines have 4 different states. There's the G3 hot rails, which are always on. Even when the machine is turned off, everything is turned off, they will always be on. Then there's the S5 rails, which are the ones when the computer is in a powered off mode. And then the next one are S4, which is when the computer's in hibernation. There aren't very many of those. There's only a couple of them. There's the S3 rails, which are for when the computer is asleep. And then there's the SO rails for when the computer is on. So if you have an S4 rail, or if you have a S5 rail, all the G3 hot rails are present. If you have an S4 rail, all the S5 rails are present. If you have an S3 rail, then all the S4 rails are present. And if you have an SO rail, then all the S3 rails are present. So you can test it quickly by just testing one from each one. and figuring out which is the first one that's missing. If you get to an SO state and the one you measure is there and it's still not turning on, then you might want it to go through every single SO power rail and figure out which specific one is missing. So the next thing I'm going to test is PP3V3S3 because, to be honest, the S5 ones are rarely missing. There are sometimes, but I'm going to go ahead and just jump to S3 just to save some time. And like I said, if I have to go back and check, then I will. But usually you can skip around and save yourself some time. That way you don't have to test literally every single rail. Which, if you want to, you can test every single rail. I'm not going to stop you. It's just, if you do it smartly, a lot of the times you can save yourself quite a bit of time. Okay, so we do have PP3V3S3, so I'll go ahead and check PP3V3SO, and I think I switched over to the face. Yep, sorry about that. Okay, we do have that, so I'll go ahead and check SO, which, where can I find that? Wow, there's a lot of places. I can find it on this capacitor. Right there. And we have 3.3 volts. Which means we are in SO state, and I can confirm that because the CPU is, or GPU is heating up, which means the rail we're missing is going to be an SO one, or maybe the computer is turning on and the PWM controller for the fan is just dead. So actually I do kind of want to test that because maybe I do just have some dead fans. Since this is just a board kind of on its own, there was no screen or anything with it. Let me grab my adapter and then we'll test it out on my monitor. Only if I can remember though what I did with my adapter. Okay, you know what? Plan B. We plug it in to this and see what it does. I think this is the right kind of case. I'll just slap it into here and see if we get anything at all. I'll also plug a little USB mouse into it to see if we're getting that. Because something tells me that this computer is turning on, but it's having some kind of issue after that. Okay, I plug this in. Oh wait, helps if I actually plug the screen in correctly. Okay, if I plug in a screen, what do I get? So I still get no fan spin. But let's see if the optical drive does anything. Nope. Okay, so we are indeed probably missing a power rail. And actually, I just remembered there's a way I can verify that. I can check if SOP good is present. So the P good signals on the computer are going to be there whenever all the power rails are present for a certain state. And that's what's going to allow them from the next state to turn on. So that's why if you're missing a rail from, say, S3, you can't go to SO because the SO rails won't turn on until the S3 P good signal is present. So to see if this is worth fixing, we'll see if the P good signal for SO is present. And another thing you can check is all sys power good. So P good, P good. I'll just check all sys power good. That's probably the easiest way. Okay, where is a good place to check this? There is a capacitor over here by the RAM. It is underneath the chip, that little chip right there, and it is the second one from the right. Okay, one on ground, and one right there. And we indeed do not have that, which means we are missing an SO power. So now I'll just have to go through all the SO power rails and figure out which one is missing. Which, I mean, this of course sounds easy, but it's actually pretty tedious, especially with how many SO power rails there are. It's a lot easier for S3, S4, and S5, especially S5 because S5 only has two, and I think, yeah, S5 only has two power rails. S4 and S3 only have a few, but there's a ton of SO. But we are going to have to go through all of them. So let's get started. So PP5VSO. PP5VSO. Give me just a sec. I'm going to get rid of a hotkey. Okay, PP5VSO. We can find that on the fan power. So I'll just check right there. That's a very easy and convenient place. So right here, we get 5.01 volts. So that's good. And I already checked PP3V3SO. Oh, I forgot to put my mic back on. Next, we have PP1V8SO. How many SO rows do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Got 17 of them. We've checked 2. So let's do PP1 V8. PP1 V8 SO. And this is going to be for the GPU. So we can find this on a capacitor. No, 1V8 SO. I need the actual SO. There's going to be an inductor on the other side. I can check right there. Is that it? Yeah, it's going to be next to the PCH. I need to check the bottom. So right there. Of course, it's the one that's covering the rest. The one on ground. And one right there. 1.8 volts. This is going to take a while. 1 V8 SO CPU. So that's just going to come from one PP1 V8 SO. So that's fine. So P1V5 SO. Wait. P1V5 SO. There we go. And of course this is for the GPU memory. So I can find this on the other side of the board. There's going to be a lot of flipping. Flippy flip. Right over here. On the top capacitor of these two right here. 1.5 volts. Okay. Okay. Just checking the weather out real quick. Okay, next power rail is PPOV75SO DDR. PPOV75SO. I can find this all the way over here. Where is this? Probably on the other side of the board going that way. No, actually, it's going to be on this resistor. On the top of it. Wait, I forgot. For these, you actually have to have RAM in the computer. So let's steal some RAM from something over here. Oh my god. There we go. Okay, now we got RAM in there. I can try this again. Okay, we are missing that. What causes this to turn on? Mem VTT enabled. PPOV75 is missing. Is that... Okay. Well, that seems to be missing, and that's for memory. But I don't think that that one missing will keep the computer from turning on. So let's go to the next one. PP1V2SO. I'll just have to remember that. PP1V... No, wait, no, 2. PP1V2SO. Okay, this is going to be for powering the graphics mux chip, it looks like. And I can find it on a resistor by the graphics mux chip. That's a really tiny component. That's okay. I can measure it from there just fine. Okay, there. Okay, we got one V2. I swear, I'm going to go through everything, and it's all going to end up being there. And I'm going to be very confused. Okay, 1V05. PP1V05 SO. I can find that right over here. It looks like that little resistor. Right there. Okay, here we go. 230 millivolts. That's not right. So where is this created? Probably the the other side of the board, I'm going to guess. Where in the world is this created? R7640. R7640. Okay, so this is for the CPU. So the CPU is not turning on, however the GPU appears to be turning on, since it is definitely heating up. So why is it not turning on? Let's find that out. U7600. U7600. Oh boy. It's one of those kind of chips. Where in the world is that? That is right there. That looks all fine and dandy. So we have PP5VSO coming in over here. Actually, I just want to check. Do we have the enable signal? Where is that? That is going to be right there. Okay, we have the enable. And we have PP5VSO. That's going to be coming in right here. Really? Which means that more than likely that chip is going to be bad. That's going to be right there. Get the hot air turned on. Can you guys still see that? Yeah, you can. Yeah, I'll have my face back in there. So this chip right there that's in the middle is going to be what creates PP1V05SO, which powers the PCH part of the CPU. And that is not turning on for some reason. The enable signals are there and the power's there. So we're going to go ahead and replace the chip and see if that fixes the problem. Now something you want to watch out for is that if you check and see before you go on replacing something like this, usually you want to check and see if the enable signal is there and the power port is there, because if those are not, then the chip will never turn on even if it's good. However, I checked both of those. Or, I mean, if it looks horribly liquid damaged, we can just go ahead and replace it, and that'll probably fix your problem. Okay, and let's go ahead and pull the one from the donor board, and then we'll slap it on there. And I'll go ahead and clean that up a little bit, get rid of the excess flux, and then hopefully we'll have it working well. Okay, it should be cooled off now, and it's all cleaned up. So I'll go ahead and plug it in. And, well, it's doing a thing with cycles, maybe. Oh, that fan spun for a second there. Okay, well, it's acting like it wants to turn on. What if we do the power on path? Nope, still isn't turning on. It starts and then immediately stops. Hmm. Trying to think what to do. Okay, let's go back over to this area, because I'm pretty sure find all sys power good. That was right here. Okay, I'll go ahead and check all sys power good and see if that's coming on now. I mean, we're making progress. We are making progress. It is at least trying to power on now. Trying and failing. Now, to figure out why it's failing. All sys power good is not present. Are we in SO power state? PP5VSO. I'm going to take a random guess that we're not. Just a completely random guess. Okay, so right over here, there are a bunch of, yeah, I'm not going to measure there. It's a horrible place to measure, but we can measure with this cap right next to it. PP5VSO. Okay, so it's not. So it turned off completely. So there's a few things that can be causing this at this point. The most likely of them is going to be the charging chip right over here. And it's going to be that the computer is detecting it's drawing too much current and shutting off because of it. Excuse me. So on the board view, that is right here. So charger CSO, so right here, this is what I need. Or no, I think it's CSI actually. Okay, good. This is unplugged. So both of these should have a fairly low resistance on them. My guess is going to be that one of them has a high resistance on it. So from there to there. Right, no, it's from there to there. That's right there. 20.2. Oh wait, you guys can't see the board. Okay, I'm measuring right here, and that's 20.2 ohms. And the other spot to check is going to be right here. Should be like 3 point something ohms. 2.9, not close enough. So that means those are not blown. So that means somewhere on this board there is likely a blown current sensor. I'm going to guess it's on the circuit that I just fixed. Otherwise, it would be shutting off. So let's see, I just fixed this. PP1V05 SO. Okay, yeah, so R7640. Where is that? R7640. That is going to be on the other side of the board. Right there. That's going to be my current sensing resistor for PP1V05. So this should be a very, very small value. Very, very small. And we are getting 0 ohm, which means that is perfectly fine. So at this point, I will probably just go ahead and check every single current sense resistor, because one of them somewhere, there is one blown. And of course, I'm going to have to take the heatsink off. Yes. How's the weather looking now? Not too bad. Not too bad. But I'll probably go about maybe 5 to 10 more minutes on this stream, and then I think I'll call it good. If I don't finish this by then, I'll probably finish it in the next video. But hopefully, I can get this fixed in the next 5 minutes, since I'm fairly sure I know what's wrong with it. Okay, put that on. I'll just put these on dialed mode. Now let's check every single one. Good, 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 good. I just dropped my phone. Drop this one. Yep. Any more? I don't think there's any more. Here's one. That's fine. Some more down here. 37. This one I'll probably have to come back to. That kind of problem is honestly one of the hardest ones to fix. Since it was coming on before, that kind of helps me narrow down the problem, because that lets me know a lot of the times when this happens, it's some clock issue or current sensing issue. But I know it's definitely not a clock issue since it was coming on before. Though maybe it is, and the clock just wasn't screwed up enough. But like I said, I'll have to come back to that since we're at 3.5 hours now. So I hope you guys enjoyed this stream. Just a reminder that I'll probably be going through and editing this into individual boards so that you can quickly just see what I did on each individual one. So I hope you guys enjoyed the stream.